Hello, my name is Mary Jo Finder and this is Math for Middle School. Today we're going to be going over how to use laws of exponents to multiply monomials. What you'll need today is paper and pencil. Okay, take a quick second to get ready to learn. We're going to talk about laws of exponents, particularly the product of powers. And our goal for today's lesson is to use laws of exponents to multiply monomials. You might be asking yourself, okay, well, what is a monomial anyway? And a monomial is an algebraic expression consisting of one term. And I have four different types of monomials. They can be as simple as x or 49, or you can have the variable term 3x. You can also have 4x cubed or 4x to the third power. These are all single term expressions. You might be asking yourself, okay, well, what is a term? A term is either a single number, variable, or numbers and variables multiplied together. Terms are separated by addition or subtraction signs, or sometimes by addition. Now I have an equation here, 7x minus 4 equals 17. I've drawn red boxes around each of the terms to show you. Notice the part on the left, that expression, the terms are separated by a subtraction sign. So let's take a quick moment and complete a T-chart to see if we can classify monomials. So draw your T-chart quickly. On the left-hand side, write the term monomial. On the right-hand side, write your term non-monomial. We have 6 expressions to sort. I'll read them to you and put them in the category that you think they belong. The first is x. The second term or expression is x minus y. 3x to the 5th power. 7x y squared. 15 y plus 2. Okay, hope you have those all sorted. Let's go over them very quickly. So the variable x is a monomial. It's a single term. There's no addition or subtraction involved. The second one, x minus y, is not a monomial. Remember, monomial means expression with one term. Well, x minus y has two terms. It's the two terms x and y are separated by a subtraction sign. The third, 3x to the 5th, is a monomial. It's a single term, no addition or subtraction to separate the terms. 7xy to the 2nd power. That is also a monomial. The number 15 is a single term, so that is a monomial. And y plus 2 is two terms. The y and the 2 are separated with an addition sign. I hope you got those right. If you did, pat yourself on the back. Nice job. So let's continue. Product of powers property. Well, we talked about powers the last couple of times, and we know a power is created using a base and an exponent. The term product means to multiply. So what if we are multiplying two powers together? So the term or the phrase simplify just means to write in the fewest number of letters or the fewest number of terms. So if we remember that 4 to the 2nd power is really 4 times 4, and our second power is 4 to the 3rd power, remember when we extend that out, that's going to be 4 times 4 times 4. Now we have repeated multiplication all the way through. So if we count up those 4s quickly, we notice that we have 5 of them. So we're going to put our base of 4 back. Because we're multiplying 5 4s, we're going to put the 4 to the 5th power. So we can say 4 squared times 4 cubed is equal to 4 to the 5th power. Have you noticed a shortcut? There is one. And let's do one more and see if you see it, because this is the background for the product of a powers property. So our example here is 3 to the 4th power times 3 to the 3rd power. So if we extend 3 to the 4th power out, remember that's 3 times 3 times 3 times 3. And if we extend 3 to the 3rd power out, we're saying 3 times 3 times 3. Now we're multiplying all of these together, so I'm going to put parentheses so you can see which set of expanded notation goes with which power. Because we're using repeated multiplication, we can write this, we can count the 3's up. Notice there are 7, counting left to right. So that's going to represent my exponent, and my base is going to remain the same, 3. So we can say 3 to the 4th power times 3 to the 3rd power is actually 3 to the 7th power. Did you see the shortcut yet? Or why product of powers works? If you notice, if I add my exponents together, what's 4 plus 3? I hope you're saying 7. Notice the 7 is the same as the 7 in my simplified version, 3 to the 7th power. The product of powers property says if I have the same bases in my powers, all I have to do is simply add my exponents together. And we can verify that by actually looking at our expanded form for proof. Let's try another one. This time I'm going to give you a couple seconds head start. So we're going to continue to use product of powers property, and I want you to simplify 5 to the 4th times 5. Do you see an issue? You might be saying, well, there's no power or exponent on the second 5. Well, there is one. It's implied, and it's an implied 1. So you can still use our shortcut or our powers property by recognizing that that invisible 1 is there. So remember our product of powers property says all we have to do is keep the base and add our exponents. I hope you added 4 plus 1. That equals 5. So our simplification of our expression is 5 to the 5th power. It's not as hard as it seems once you get the trick. One more time, give you a couple seconds head start. Simplify x to the 4th times x to the 2nd. Good job. You added 4 plus 2. 4 plus 2 is 6. So the simplification of our expression is x to the 6th power. Let's try it one more time, but this time let's add coefficients. Coefficients are the multipliers in front of the variables. Now there's a trick to this. We have to multiply our coefficients together, and then we have to multiply our powers together. So the way this would look is I would multiply my 3 times 2, and then I'm going to multiply my x to the 2nd power times x to the 5th. Now I know negative 3 times 2 is negative 6. I now know, using my exponents property, that I can say x to the 2nd power plus 5 thank you, is x to the 7th. All I have to do is put my coefficient and my power back together. So that would be negative 6x to the 7th to have my simplification of my expression. One more time, very quickly. Give you a couple seconds head start. Okay, good job. Take your coefficients. 2 times 4, yep, that's 8. Multiply your powers. Now remember, the x in the 2x doesn't have an exponent, so there's an imaginary 1 there. So we're going to say x to the 1st times x to the 5th. Okay, so we're going to say x to the 1st. Oh, let me erase that and try that again. So I'm going to say x in parentheses, or in my exponent, 1 plus 5. That's going to equal x to the 6th. Take and put my terms together. That's 8x to the 6th power. That's my answer. Now it's your turn to practice. I have 3 practice problems for you, each of them involving the product of powers property. Simplify, that means to write in the smallest amount of terms. Make sure that you're writing as powers and using exponents. I'll read the problems to you so you can write them down. 6 to the 5th power times 6 to the 9th. 12 to the 3rd times 12 to the 4th. 4x cubed times 5x to the 5th power. Good luck. Keep practicing. That concludes our lesson for today. Let's have a quick review. Today you learned that when you multiply powers with the same base, you can add the exponents together and arrive at the same product. Remember this week to work on your product of powers property so you can continue to improve. It's been my pleasure to have you in class today. I'm Mary Jo Fender. See you next week.